Binomial radical expressions. Here we're going to first review simplifying just radical expressions in terms of adding, subtracting, and multiplying, and then look at multiplying binomial radical expressions. We won't look at division here. So for example, let's add and subtract the following radical expressions. Our first example, 7 radical 5x plus 8 radical 5x. Now in order to simplify and combine these, the radicals must be identical. So here we've got the square root of 5x as our radical. What's underneath the radical is identical, and the index of the radical is identical. So since they are, we can now combine the terms on the outside. 7 plus 8. 7 plus 8 is 15, so 15 radical 5x. Let's look at a second example. 11 fifth root of 4x minus 8 fifth root of 4x. The radicals are identical, so 4x is underneath the radical in both cases. The index is 5 in both cases. So now we can combine the outside terms. 11 minus 8 is 3, so we have 3 fifth root of 4x as our answer. Okay, let's look at an example where we need to simplify before we add or subtract. Got the square root of 12 plus the square root of 75 minus the square root of 3. So we need to simplify these radicals before we can add or subtract. As they are now, the radicals are different, and we can't do anything until we simplify them. So 12 can be rewritten as 4 times 3. 4 is the largest perfect square factor of 12. The largest perfect square factor of 75 is 25. So we can rewrite that as the square root of 25 times 3. And 3 doesn't have any perfect square factors, so we leave it just as it is as the square root of 3. Okay, so the first set we can rewrite as the square root of 4 times the square root of 3 plus the square root of 25 times the square root of 3 minus the square root of 3. Simplifying further, we've got 2 radical 3 plus 5 radical 3 minus radical 3. So now the radicals are identical. We've got 3 underneath the radical. The index is 2 in all cases. So let's combine the outside terms. 2 plus 5 minus 1. We are left with 6 radical 3, and that is our answer. Okay, let's look at multiplying. If I've got 3 minus the square root of x times 7 plus 2 radical x, we are going to distribute just as we've done in the past with binomial expressions. So 3 times 7 is 21. 3 times 2 radical x. We're going to multiply the 3 times the term on the outside of this expression, so the 2. We get 6 radical x. Negative radical x times 7. So the negative 1 gets multiplied by the 7. Negative 7 radical x. And negative radical x times 2 radical x. Negative 1 times 2 is negative 2, and we get the square root of x squared, which we can simplify to x. So we have 21 plus 6 radical x minus 7 radical x minus 2x. We can simplify or combine our middle terms because they have the same radicals. We've got x underneath the radical. Both of them have index 2. 6 minus 7, we are going to get minus radical x. So we now have 21 minus radical x minus 2x, and that is our answer. Let's look at a second example. Here we have the first terms are the same, the second terms are the same, and the only thing that's different is that we have a minus in one case and a plus in the other case. These are considered conjugates, so they're identical except for the sign in between the two terms. So 4 times 4, 16. 4 times radical 6 is 4 radical 6. Negative radical 6 times 4 is negative 4 radical 6. Negative radical 6 times radical 6 is negative 6. Because remember, it would be negative square root of 6 squared, which is negative 6. Okay, our middle terms cancel. They combine to form 0. So we're left with 16 minus 6, and 16 minus 6 is 10. So our answer to the second problem is 10. When we multiply conjugates, we will not have radicals in our answers.